Okay, so today we're in topic 9, probability, and we're in block 1. In today's lesson, our goal and objective is to find the probability of a simple event and make predictions based on results from experiments or theoretical probabilities. So, I want you to think about your favorite game show that you've watched. And in that, just say for instance, like you're talking about Wheel of Fortune, or there's other games where you have to be called down to the road to actually even be able to participate in the game show. There's chance that's involved just to be called, right? Don't you think? So what determines the chances of winning that game? Has anybody ever watched Wheel of Fortune where you have to guess the amount of money that something costs? Or not really? Nobody's really watched that. Anybody got a game show? I can use your game show. Give me a game show. No one's watched a game show. The Price is Right. Yeah, The Price is Right. Perfect. All right. So The Price is Right. You have to be called down to be able to participate in that, and you got to know about what the price is, because the purpose of that game is to guess the closest price to the item that they're presenting, right? So is it likely that someone's going to win that game? Once you get all the way down to the last two people? Yeah, that's pretty likely. I would say so, because whoever's closest is going to win, right? What would be the chance of that person winning since there's only two people there? 50%. Yeah, 50%. How were you able to get that? Just two people. Yeah, there's two people. Yeah, 1 out of 2 would be 50%. Perfect. So do you think that game is a game of skill or chance or both? I agree. I think it's both, because you got to have some luck to get called to be able to participate, and then a little bit of skill, because you got to know what stuff is priced, so that whenever that opportunity comes your way, you can actually give a close price so that you can leave from the bottom floor and actually be able to participate and get to spin the wheel, right? So how would you determine what your chances would be of winning if you went on the show? That's kind of tough, isn't it? How many people are at the bottom of the floor at the very beginning of The Price is Right? When they call everybody down, they're like, "Come on down." How many people are down there on the floor? Is it 4 or is it 5? Does anybody remember? I think 5. Okay, so let's just say there's 5 people and you get called down to the floor. What is the chance out of those 5 people that you are going to be closest when you make that guess? How would you find out that chance? 100 divided by 5, because there are 5 people and you could have 100% if it was just you. That makes sense. So you're saying that it would be a what percent? 20% chance. Good. That's great. And so the way that I think about it is I do it a little different than what Emma said, but that way worked perfect. I do 1 divided by 5 and then multiply by 100. Emma just said take 100% and divide it by 5 people, and that tells you that it would be a 20% chance. So that's a great job. Perfect. So let's take a look at this. If you would, go ahead and start us off, Tashandrick, with overview page 1. Would you read that for us?
You have already represented and integrated data. You can also use data to find out how likely something is. For example, if you put 2 numbers used, likely is a sum of 10. When you determine how likely something is, you are finding the probability. To begin your investigation of probability, conduct an experiment with the guess and win game. You will roll two number cubes 12 times before you roll guess with the number two cubes for each. Will add up to for each of, of your 12 guesses. Place a blue marker on the number line.
All right. So we're going to roll these two number cubes. How many times? What'd they say? 12 times. Now it says to guess what the number cubes for each roll will add up to before you roll. It says for each of your 12 guesses, place a blue marker on the number line. So let's go with Sarah. Sarah, tell me what you think is going to land. What do you think we're going to roll?
Uh, uh, two balls and then put them down like on like the number two line, maybe.
All right, so I'm going to put it here.
Yeah, yes, sir.
All right. So we think it's going to be two. Let's roll these dice and see what happens. When you've placed all of your markers.
All the balls in this section are like in.
Oh. All right. So the first time Sarah said maybe two. All right. So what do you think, Zayden? What's another one that they might be? Go ahead, Eli.
4.
All right. Eli said maybe four. All right. Layla.
6.
What do you think, Abigail?
1 on 7. I don't know.
I was kind of thinking seven also. All right. What do you think, Isabella?
3.
What? Let's keep rolling. What do you think, Chris? What number do you think we're going to land on when we add the two dice together? Give me a number, Jemiah. Chris will give me one in a second. Be thinking of your number right now. Roykia, what number are you thinking?
9.
9. All right. What are you thinking, Jemiah?
I said probably like 4.
4. All right. Lainey, what you think?
Maybe 2 on 10.
She said 2 of them on 10. She thinks it's going to land on 10 twice. All right. What about you, Deonti? What you think? What do you think, Deonti?
I'm not too sure.
You don't have any idea what number it might land on? Just take a guess. What's your favorite number out of those numbers? 8. All right. And then let's see. Destiny, what do you think? I'm gonna do mine on 11.
5.
5. All right. Let's see what happens. So let's roll these cubes. See what we get. It says we're gonna earn a point for each correct guess. First one we got 10, so we got 1. Let's roll it again. Got a 9. So far we're doing really good. Oh yeah. Whoa. All right. So we just lost a point because what happened? We rolled 9 how many times? Twice so far. All right, we got a 7. We got a 6. Got a 7 again. Got an 8 again. All right, we're trying to come back. Dang. All right, so it says, how many sums did we guess correctly? How many did we get right? We got 6. So it says, can you think how to change your guesses so that we could get more right? Looking at that data right there, what would you probably pick next time to get more right?
7.
Yeah. So really, basically everything that's completely blank, it looks like numbers 5 through 10 are getting hit the most, aren't they? 10 got hit once, 8 got hit a whole lot, 9, 5, 6, and 7, right? Which one got called the most? What number got called the most?
9.
Yeah, I think 9 did get called the most. So if we were to do this again, what do you think we could do?
Pick the numbers that got hit the most.
Yeah, and then we'd have a better chance of winning, right? All right, let's take a look at page 2. All right, so it says, were we surprised by the results? Were y'all surprised, or was that pretty kind of what you thought? I felt like based off of what we answered, it was pretty close, huh? Yes, no. Emma said yes. All right. So were some of the sums more likely to happen than others? Which ones?
7 and 8.
Yeah. 9 happened the most, and 7 and 8 also. Now, if we were looking at theirs, what would have happened the most on theirs? Well, nothing really. It looks like 8, 9, 10, 11, and 12, and 2 got called the most on their game, huh? So it says, were some of the sums impossible? Are any of these sums impossible to happen?
No.
No, I don't think so. Because the dice could have landed on 1 and 1, that would be 2, and we could have landed on 6 and 6, and that would have been what?
12.
12. So the only numbers that would have been impossible would have been what? Give me some numbers that would be impossible to roll out of that.
1.
1, good job, Eli. What's another one?
0.
0, good. What about a number bigger than 12?
13.
Yeah, 13 wouldn't work also. So it says
7.
in this,
100.
yes, so that would not work. So in this topic, we're going to learn to use probability to predict results in experiments like this guess and win game. So we're going to play the animation to explore some important vocabulary related to the study of probability. So when you roll the number cubes, you cannot predict exactly what the sum will be. All right, so we're going to roll them and see what happens. Let's just take a guess. What do you think, Eli? What's it going to land on?
8.
All right, Eli says 8. Anybody else got a guess? I say 5. Let's see what happens.
9.
Oh man, we were all wrong. But that's okay. So when we roll the number cues and we record what happens, we're conducting a what?
Trial.
When we roll it, we're conducting an experiment. Each time we roll the number of cubes, we perform a trial, like Eli said. So when we roll the number of cubes and we record what happens, that's an experiment. But every time we roll the number of cubes, that's performing a trial. Okay? So the first time we got 7. And so it says the event that occurred was rolling 7. And that was all of the outcomes would be all of the possible sums. So, for instance, we had 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those are all possible outcomes. So, read that for us down there at the bottom, Abigail.
All possible sums are called the outcomes of the experiment. Rolling a particular sum is called an event. Events are the results of experiments or observations.
All right. So, an event is what takes place after we roll the dice, right? When we see what happens after something occurs. So it's an observation. So the experimental probability of event is the ratio of the number of times the event occurred to the number of trials in the experiment. So we're going to click the roll cube button to see an example. So if we roll the cube, we got 9. She's going to roll them again. She got 6. Then our next time, we got 4. And on the 4th roll, what'd she get? 7. So how many times did the event occur?
4 times. Wait.
Well, we only had one. It says number of times the event occurred was 1 out of how many times? 4, because it says experimental probability of rolling a sum of 6. Well, we only rolled 1 6 out of 4 times. So that's a 1 out of 4 chance that happened, right? Yes or no?
Yes.
Thank you. All right. So it says probabilities can be written as fractions, decimals, or percents. So as we continue to conduct experiments, we're going to see that the probability of any event is always a number between 0 and 1. So the closer it is to 0, the less likely it is to occur. The closer it is to 1, the more likely that it's going to occur. If it is 0, it would be impossible. And if it was 1, it would be certain that it would happen. So remember, this right here is very important. And I suggest that we write that down so that we remember how to find this information. So they took the what first?
Number of times the event occurred.
And they divided it by what?
The total number of trials in the experiment.
All right, that's very important that we remember that, because that's how we're going to find our probability. So everybody needs to write that down. The number of times the event occurred divided by the total number of trials in the experiment. All right, everybody should have that written down. Let's take a look at page 4. So what I want you to focus on is I want you to use your previous knowledge or the resources that we have to record our definitions and examples. All right, on 3 and 4. And what we're going to do is we're going to answer question 1 in our workbook by doing this. So it says you've seen the probability is useful for designing and winning games, but probability has many other applications. Probabilities are used in many different professions, and so we're going to click on the images to see how. So looking at this guy playing baseball, what do you think probability is used for him?
How many times he hits the baseball?
Yes. And that's called a what?
Experiment. Event.
All right, and it's actually a what?
Batting average.
Yeah, it's a batting average. And so batting averages are probabilities that are used to predict how a baseball player will perform in their game. So in other words, like Emma said, how many will he hit the ball when he gets up to bat? If he is now batting averages are normally in the thousandths place, but if he's at 100 thousandths, is he likely to hit the ball? Like if he has a batting average of 100 compared to somebody that has a batting average of 900, which one's more likely to hit the ball?
The person with 900.
Correct. Because that's like a 90% chance that he's going to hit the ball, and the person with 100 is a 10% chance. So isn't a 90% chance more likely to hit than a 10%? Yeah. All right, let's check out this lady, and looks like a weather person. What's that say, Abigail? Abigail.
Some type of that looks like the United States, but I don't know.
All
Some
right.
weather
So
thing forecast.
look at what it says in the yellow.
She must be, or it must be like the forecast for the weather. I don't know.
Okay. So meteorologists use probabilities to predict the weather. Good job, Abigail. So are they always right? When they tell us it's going to snow in Louisiana, does it always happen?
No.
No. Most of the time it doesn't. But they predicted it that way, and there was a chance of it happening. Just most of the time, it doesn't occur that way. It's supposed to snow Monday, but we'll see what happens. Right now, they're calling for 3 to 5 inches, and that's a lot for us because it hardly ever snows. So if it snows twice in one year, I'm gonna be very happy because that like never happens.
Me too.
I don't know what this cat's doing. What's he doing? What is that, Eli? What is in his hand?
Maybe they're making up for COVID.
I hope so. What is that? A water. What's he doing right there?
It looks like he's making a fountain or something.
All right. That guy's happy. So he uses probabilities when choosing sites to dig wells for water. So, honestly, I think farmers are a little bit smarter than that. They probably drive like a stick down in the ground or something and see if it gets wet when they put the long metal tube down in the ground. And if it's wet, then they dig a hole there. If it's not, they don't. But if they have, hundreds of acres of land, then they have to use some type of probability, right? So that they know where to go to find out where water's going to be. Do y'all think so or not think so? I got some head nods. Y'all got to talk up some. You got to remember, I got you on camera. You got to talk. They don't see your face. They just hear your voice. Y'all are my YouTube famous people.
You gone viral?
Yeah, I'm viral right now with like 4 people. Jokes. I'm just joking. And Isabel's one of them. Isabella. All right. So, what we're going to do at this point is everybody should have question number 1 answered. Okay. And what we're going to do is we're going to look at our more practice pages 1 through 5. Now, before we do this, I want to ask you a higher order thinking question. So, anytime you're asked to play a game, how can you determine? That was scary. How can you determine if a game is a fair game? Like, how could you determine if it was fair? Like, if say you have a brother or sister, and they're like, "Let's play a game." Every time, um, a person says like, you have to do 5 push-ups. But every time somebody says I'll do 5 push-ups. What is that? Is that a fair game? Kind of hard to say, isn't it? It depends on the person that's talking. If you are watching a show with a Valley Girl, more than likely you're going to end up doing a whole bunch of push-ups, and they're not going to do hardly any because they're going to keep saying like and 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 like, because that's just how they talk. Or y'all might not watch girly shows, I don't know, but they say like a lot. But anyways, anybody else got an idea of how you can determine if a game is a fair game? Come on, man, y'all are smarter than this. How do you know if something's not fair?
If there's cheating involved?
Yeah, if somebody's cheating. All right?
If one has to do more push-ups.
Correct. Somebody has to do more than what somebody else does. That's not fair. All right, so let's take a look at what Gianna is doing. Sarah, go ahead and read about Gianna for us.
Gianna flipping
A two-sided coin?
Sometimes I have trouble reading. I stutter a lot.
That's okay. You want me to read it? And you can answer it?
Sure. Yeah.
Gianna is flipping a two-sided coin 50 times and recording how many times the coin lands on heads. Drag the tiles to complete the statements. Flipping a coin repeatedly and recording the results is an what?
Experiment.
All right. The blank are landing on heads and landing on tails.
The outcomes.
She will conduct 50 what?
Trials.
Good. To see how many times the blank landing on heads occurs.
Probability. Event.
Good. I was going to say probability could possibly go there, but because it is the probability of landing on heads, but we're trying to see how many times the event landing on heads occurs. Do y'all agree with what Sarah said for number 1?
I agree.
Okay.
I agree.
Let's check it. Perfect. Perfect job. All right, let's take a look at number 2. Layla with an H. Will you try this?
Yeah.
All right, the wheel is spun 25 times. Drag the tiles that best describe the probability terms.
The experiment spinning the wheel.
Okay. What is the number of trials?
When y'all were talking about it, I was taking my test. So.
Oh, my bad. You're doing good, girl. So somebody help her out. So what is the number of trials here? What do you think, Haley?
25.
Good, because that's the number of times that we've done that, right? What are the possible outcomes?
Blue, yellow, and green.
Great. And so an event would be what?
Blue.
Okay. What would be the probability that it would happen? What would be the probability that you would land on blue? What do you think? How many blues are up there?
33%.
It would be 33% because it's one out of how many? Three. Good. So the probability would be 1 out of 3 or 33%. We're doing a great job. I'm very proud of y'all. All right, Najela. Calculate the experimental probability of landing on heads given the data shown. It says the experimental probability of landing on heads is what?
22.
All right, let's see. We got 22 times that we landed on heads. We got 5, 10, 15, 20, 25 plus 3, 28 times that we landed on tails. So how many times did they flip the coins, Najela?
50.
All right, so in all, they flipped it 50 times. How do you know that?
Because 28 plus 22 is
Good. And so out of 50 times, how many times did they land on heads?
22.
Okay. So that means 22 out of 50 times they landed on heads. So how can you determine the probability of landing on heads?
Divide by 100.
What do y'all think? Can y'all add to what Najela's thinking? What did we write down earlier? Say that again, Emma.
That wasn't me.
Oh,
You could do 22 divided by 50.
good job, Haley. All right, so who remembers what we wrote down earlier when I said it was important to write it down? What did we write down?
The number of times the event occurred divided by the total number of trials.
Correct. All right, so we know there were 50 trials and it occurred 22 times. So 22 divided by 50 is going to give us our answer, Najela. So what's that going to be? What would that be? Would we leave it at 0.44 or could we say 44% or what? How would you say it? Somebody help her out.
44%.
All right, so 44%. What's another way we could say it? Go ahead, Sarah.
44 over 100.
Great. So 44 hundredths. Or we could just put it in as a decimal, right? As 44 hundredths, just like you said. So let's see if we get that right. All right, looking at what we did, it says the definition of experimental probability, just like y'all said, was the number of times the event occurs divided by the total number of trials in an experiment. So our fraction was 22 divided by 50, which gave us 44 hundredths. All right, let's take a look at number 4. All right, looking at number 4. To Chandrik, there are 2 types of large fish in the lake. We have carp and bass. A game warden is trying to estimate the number of carp in the lake. Out of 25 random samples of large fish, 12 were bass. So, what is the experimental probability of selecting a carp? So, we know that 12 out of 25 are bass. So, how many would be carp out of the 25?
13.
Good. How'd you get that?
12 means 25 minus 12 is 13.
Good. All right. So, what is the experimental probability of selecting a carp? What would you say there, Tashandra?
13 over 25.
Good. Everybody understand how he did that? Who can restate what Tashandrick said? What did he say to do to find that answer? Nobody too quickly.
He subtracted 12 from 25 and got 13, and then he found the answer, which was 13 after 25.
Great job. All right. And lastly, for our lesson today, we have choosing a card without looking at the value is central to many card games. In this game, there are 5 cards. Fill in the blanks to describe the game. Be sure your outcomes are in alphabetical order. Isabella, if you randomly choose a card without looking, there are blank possible outcomes for our choice. How many possible outcomes are there? Come on, Izzy. How many outcomes are there?
I don't know.
You're not sure? Let's look. We got 1, 2, 3. It is 5. Correct. Does that sound right, Sarah?
Yes, sir.
All right. So there's 5 possible outcomes. The outcomes are what?
A,
Good.
C,
Good.
D,
Correct. Because our only possible outcomes are picking what letters?
A through E.
A through E. Correct.
Yeah.
Does that make sense?
Yes, sir. Yes, sir.
All right. Izzy? You good? That makes sense? I can't see your face.
Yes, it does.
All right. Good deal. Okay, so this concludes our class for our lesson on topic 9, block 1.